Hello, welcome back to another episode of SHENZHEN IO. Since last time, they've updated to 1.1. 1.1 adds a few new parts, FM-based synthesizer in the sandbox, a note part, which can be placed anywhere. Most of the parts are now unlocked at the start of the game, but are soft locked to discourage inexperienced players from using them prematurely. They also reordered a few of the mid-game puzzles. So I do see one puzzle, so if we check out our mail, there's one puzzle, the pollution sensing window, that got moved up. So I don't believe we've missed anything else. So let's do that one. He says, I'm working on a smart window that reacts to particulate matter in the air, pollution. I need a controller that allows us to close the window when the level is too high and opens it again when the level is lower. Alright, let's check this out. So we have our new note part. It looks like the notes can't be placed directly on top of other parts, but they can be placed off board without any issue. And then you can write in them like hello, stuff like that. I don't know how useful they'll be, but I imagine if you want to comment stuff. And see, these are all pretty familiar. We have the logic gates that we haven't really found a use for yet. They're pretty expensive for just a simple NOT. And so on, and or, and XOR. Then we have this thing. I don't know what this is. If I go look at the manual for this thing, it's called the PGA 33X6, but the manual's in Chinese, so I can't read that. So I imagine you just have to play with it and see what it does. Alright, so let's read about this problem. Pollution sensing smart window. Sensor is a simple input connected to an air pollution sensor. So we have sensor. Alright. Window is a simple output connected to a motor that opens and closes a sliding window. Window should be closed, signal low, when the average sensor reading for the 8 most recent time units, including the current, is greater or equal to 50. When the average is greater than 50. So it's 100, and then it's closed when it drops. So it could be closed. So close it when it's greater or equal to 50. So apparently here the average was right here, became greater or equal to 50. And then it dropped down to 33 and 0. And eventually the average jumped up to 100. When the average sensor reading for the 8 most is greater or equal to 50. So since there's no divide instruction, it seems like you have to add these inputs, the last 8 of them, somehow know the last 8 of them. And then if it's greater or equal to 400, then that's an average of 50 for the last 8. Now the question is, since you have to remember, it's a sliding window average, so when you tick over here, you got to throw away the 8th one away over here. So you always got to remember the last 8. So you can't just keep adding till you get to 400, and once you get to 400, close it. You got to keep computing the sliding window average thing, which seems to imply that you need a logic gate, memory storage, and every frame you would add one more to the end and just read all 8 every frame. Guess that would work. Seems a bit tricky, but I guess it's possible. It's almost like you want one writer and one reader, maybe? Something that's always... Try setting it up as one writer and one reader. I don't know. Let's see where we get to. Alright, so we need a pin on this one. Let's just say move P0 into X1 and sleep 1. Let's Let's watch what happens there. So look, that's correct in terms of 0, 0, 0, 30, 30, 60, 60, 66, 3 100s. So that looks like it's correctly writing, and then if I keep stepping, it's repeating, it's just automatically looping around, which is nice. And if I just go back 8 from where this last was, it'll have a number for me. I might be able to do it in one circuit. I'm sure somebody has. But it might get tricky. Let's keep it 7 for now, just to keep it simple. Let's see, what we want to do is, this is a pin? Yeah. Let's see, we want to control these two guys. We'll initialize A1, move A1 to, let's see, 14. Is that where the start is? Not A1, X1, which is routed to X1. Move 14 to X1. Let's see, where does that go? 13. Oops. All right, 13 is this one, so that's 1 unit back. So 12, 10. So it's almost like you want to -7, so let's try 5 maybe. And then it could read 8. Let's move X1 to AC. Add X1, let's just try manually adding X1 a bunch of times. How many times we got to do it? We should do it 4 and then 8. Let's see what happens here. It's not actually, oops, sorry, not X1. We need to move X0 because X1 is pointing to our address. We don't care about the address. We want to care about the data, and the data is going to move the address automatically. All right, so the last one should have been, let's try 6. Okay, we also want to read the current. So let's try 7. No, we're still not reading the current. Let's try 8. Is that right? Oh, yeah, we were. So 7 is right. Yeah, 7 is right. All right, so that's where it should stop. And then we just need to see if we use our AC to do a loop. It's going to get tricky because I can't add. What if I just do it this way? Test if greater than 399. Test if AC is greater than 399. If it is, we'll move 0 into P1. Otherwise, we'll move 1 into P0. Or P1. Now, the only trickiness now is we got to... Is that going to be right? Now we just need to move back by 7. And maybe that's really what we need to do, is instead of this at move 7. I wonder if it wraps though. What happens if we pass in like negative numbers to this thing? What does it do? Oh, it actually does work. Let's pass in -2. -2 do the right thing. Yeah, it does work. Wow. That's nice. So you don't have to do complex logic around the addresses. You just pass -2. So we'll just say move A1 into AC, subtract like 8 maybe. No, X1, sorry. Subtract 8 and then move ACC into X1. Something like that. Let's try that. I think we want to subtract 7. That looks right, but it's not sleeping, so therefore it's not working correctly. You could do it real cheaply by almost just moving all this stuff. Move this up. This is real inefficient. I think it would work. And then instead of doing that, we just move ACC to X2, and then it does the test if sleep until X1's available, and then test if it's greater than 399, test if X1 is, and if it is, then we'll move 0 into P1, otherwise we'll move 100 into P1. And then we can sleep on this guy. Let's see. Well, there's a simple way to do it. It's not very efficient. I highly suspect you should loop these things. Let me just simulate this. And then I'll run through an optimization pass. Yeah, as expected, my production cost is pretty high. Let's return to email, see what they say. Good. By the way, maybe you noticed that the sliding window algorithm for a sliding window. Do you think that is funny? Okay. Let's copy this. See if we can get this a little bit cheaper. Obviously, this is pretty inefficient. I could probably get rid of this guy. No problem. So let's see if I can do that. So I need to write it somewhere. We have an extra instruction. Let's add P0 and move P0 into X0. Let's move this apart so I can actually see the names. Let's see if that works. Yep, that still works. That's a bit better. So let's see, I'm now at $10. Let's see, it looks like the leaderboard, the big leaderboard was around 6. So it looks like for $6, you should be able to, it's almost, is it talking about, yeah, it looks like a lot of people were at 6, looks like. I wonder how they got exactly 6, because I'm thinking if you need this memory unit, then what would you also include? Could you do it with like one of these and a memory unit? I don't know, that seems pretty aggressive. Like, obviously you don't need all these instructions, you could do it differently. And then maybe get rid of this guy. The tricky part with this thing is there's a... you'd have to keep swapping between DAT and ACK to do the loop, because you'd have to say like, oh, ACK is 8, and then oh, I want to now use ACK to add this stuff up, which means there's like you're gonna have to flip between ACK and DAT a bunch, and this is gonna take a bunch of instructions. This doesn't seem like you'd make a big win. I don't see a great way to make it more optimal, because if we remove the memory, I don't think it'd be easy to keep 3 to 8 registers or 8 values in flight, because it get pretty expensive. Maybe this thing would solve it, but I don't understand how this works. There's ways to flip this stuff, so you can kind of, it seems like it's programmable. I have to play around with it to understand it. I haven't done that yet. Yeah, it's not clear. I'll be curious to learn how people do it for cheaper. Anyways, we'll stop this one at $10. That's a pretty reasonable money. A lot of people figured it out cheaper though. All right, that's a good stopping point for that episode. See you next time on SHENZHEN.io.